Hello, everybody. Welcome, and thank you for being here. Thanks for joining our webinar training on the Adapting to Rising Tides Bay Shoreline Flood Explorer. My name is Jackie Mandowski, and I work on the Adapting to Rising Tides program here at BCDC, and I'm joined by my colleagues.
Todd Holdenbeck.
And Eliza Berry.
The Adapting to Rising Tides Shoreline Flood Explorer is our new online interactive tool that allows users to visualize flooding from sea level rise and storms in the San Francisco Bay Area. And we're providing this training today to help connect how this online tool can be used to support adaptation planning in our region. Great, so I'd like to take a moment to review the agenda for what we plan to discuss on today's webinar. We'll briefly introduce the ART program and origins for developing these mapping tools. We'll also touch on the data inputs of the ART maps and the unique features they contain. Then we'd like to walk you through a demonstration of how this tool can be applied to support sea level rise planning in the region through vulnerability assessments and adaptation planning. And lastly, we'll discuss some next steps for this tool. So, the Adapting to Rising Tides program is part of the Bay Conservation and Development Commission, or BCDC. And we're a state agency tasked with protecting the San Francisco Bay and its resources. Our agency is comprised of both a permitting and regulatory component, as well as a long-range planning division. And from a regulatory perspective, the agency ensures that projects in the Bay and shoreline are compatible with the conservation of Bay resources, including maximum feasible public access to the Bay shoreline. And the Adapting to Rising Tides program is part of our planning unit. And our work in planning extends beyond the agency's regulatory jurisdiction, and the agency as a whole is increasingly interested in having to address sea level rise issues. And over the last 7 years, this has led our planning division to really develop the ART program. So the ART program began in 2011 and has done significant work across the region, partnering with local and regional municipalities, across many different sectors, such as transportation, natural land, among others. We've worked at various scales, and our work is always highly collaborative. So this slide shows some examples of the work that we've done, helping to conduct sea level rise vulnerability assessments and planning processes. And we have often led or provided support to a range of these planning processes. And in doing so, this has allowed us to create a toolkit of online guidance to support and guide sea level rise vulnerability and adaptation planning. However, all of this work relies on having high-quality sea level rise and flood maps. And we've increasingly taken a role in producing these flood maps for our partners. So we recognized early on that good assessments require good understanding of flood risks in our region. So beginning in 2015 with our pilot project in Alameda, our team, along with some partners, developed a new methodology to improve the accuracy of our mapping data for Alameda County. And these efforts were replicated in additional projects in San Francisco County, Contra Costa County, and San Mateo. And even more recently, we were able to complete this mapping for the remaining 5 counties of the Bay Area and provide a full regional view of flood risk in the region. So the products of these mapping tools have been available online in both a geodatabase download and PDF. However, now we've actually been able to take all these mapping data into a new interactive online platform. So the maps themselves were built by studying water levels in the bay today, as well as the terrain along the shoreline. And this enables us to project where water will flow as seas rise. With this in mind, there's 2 primary data inputs into the map, a water surface created by FEMA and a terrain data based on remote imaging from NOAA and USGS. So to understand what the water surface looks like today, we built off of the FEMA Bay Coastal Study, which characterized the spatial distribution of water levels across the bay. Due to a variety of reasons, water levels across the San Francisco Bay are not all the same. For example, water levels in the South Bay are higher than in the North Bay. And knowing the spatial extent of where these differences are is important to understanding more localized flood risk. And the surface water baseline in these maps represents the mean high or high water, or the average of the higher of the two tides that flush the San Francisco Bay each day. And in the graphics and in the Explorer, we often represent mean high or high water as high tide for ease and understanding of these underlying concepts. And the terrain, so the second component of our data is the terrain data, and this digital elevation model data came from NOAA and USGS LIDAR from 2010. And additionally, here we incorporated some important stakeholder review for accuracy and corrections to the map. So, because these maps are focused on the Bay Area, a unique feature is that we're able to reach out to stakeholders such as coastal management agencies, flood managers, land trusts, and other experts on the shoreline to help us identify details in the shoreline topography and flood control structures that are hard to identify but important to understanding the movement of water. This slide shows some examples of how stakeholder review improves the accuracy of our mapping tool. So, for example, in Sonoma, we were informed there was an additional levee that we needed to add to the data set, while in Santa Clara, we learned where there are some additional tide gates and some conditions of the levees. So again, all of these were only possible because we had such a specific Bay Area focus. And so another really unique feature of these maps is that they include a shoreline overtopping assessment. And this assessment shows low points on the shoreline that can overtop as seas rise, which is what allows water to flow inland. And this data layer is valuable because it can help us identify where water is coming in and where we can target solutions. And so lastly, the Flood Explorer is a unique tool because it displays what we call the one map, many features approach, which displays a single total water level that can represent different flood scenarios. So this approach allows us to consider the impacts of flooding arising from various scenarios simultaneously. For example, we can see in this graphic that a 5-year storm could create the same total water level as 24 inches of sea level rise, as well as what other combinations could cause the same level of flooding. It allows us to consider temporary flooding from storms, as well as permanent flooding from sea level rise, or a combination of both at the same time. And this is very helpful in adaptation planning because it allows us to plan for temporary inundation that could happen today, while also developing solutions for permanent inundation in the future. So to summarize those couple key points, this tool is really uniquely suited to support planning in our region due to these three features. So this very intensive stakeholder review process, the inclusion of a shoreline overtopping analysis, and the ability to address and consider different types of flooding through our one map, many features approach. And we originally designed this online tool for a wide range of users, and these include planning partners, public agencies, elected officials, and the general public, and with the overarching goals of allowing people to explore and interact with the data, learn about flood concepts, and then also download this data for their own needs and analysis. And we see here this important and unique opportunity for the tool to support our planning partners, jurisdictions, and asset managers as they carry out their own adaptation planning processes. This tool is helpful in terms of visualizing impacts and communicating those impacts to stakeholders, whether they be public or non-public audiences. So, we'd like to take a moment to walk you through the actual shoreline, the Flood Explorer itself, to better understand how this tool can be used to support adaptation planning. But before I hand it over to Todd for the demonstration, I wanted to take a moment to review the ART program's planning process so you have a better idea of how this tool can support this process. So the first step of the planning process is our scope and organize phase, where we work with stakeholders and communities to define the area and the assets that we want to assess, and we also address flooding and climate issues. So in this stage, we define flooding and climate scenarios that we'd like to use. Once we understand really our scope and who we have at the table with us, we then move on to assessing. So this is where we assess the risks through our sea level rise exposure maps, additional riverine flood maps, and our conversations with managers on the vulnerability of these assets. The next stage of our process is define, where we can begin characterizing these cross-cutting vulnerabilities within our project area. The next step is planning, so this is where we really look at how can we address the vulnerabilities we've discovered and plan for adaptation. And then our last stage is implementation, so how can we move forward in carrying out these measures as well as track progress over time. So with that, I would like to hand it over to Todd to walk us through the Flood Explorer and point out the features of the tool that help us visualize and investigate flood impacts, as well as teach key flood impacts to engage stakeholders and gather support for this planning process.
Thank you very much, Jackie. I'm going to switch over to our site now so that I can walk you through some of the major functions of the site and highlight how it can be useful in supporting early stages of a planning process. As Jackie mentioned, we've designed the Explorer for a wide variety of stakeholders, including non-technical users who might be new to flooding. The Learn section of our website can be used to help educate stakeholders in the basic concepts and impacts of flooding and climate resilience. Given the diversity of stakeholders in the Bay Area, it was really important for us to be able to communicate this information to all community members, including those that are non-English speaking. And so we provided some really useful translation functions within the website to support their understanding of these issues. Early in the planning process, it's often important to educate stakeholders about the topics related to flooding, sea level rise, and resilience. And the Learn module is designed to support this in an easy-to-understand way, providing both background about where flooding has occurred in the past, as well as introducing and defining some of these key concepts that users will need to know in order to understand the maps, both including sea level rise, king tides, and this is really an opportunity for us to also point out and direct stakeholders to some of the newest science and guidance on sea level rise, including the state of California's recently released sea level rise projections. And it gives us an opportunity to teach some of the key concepts like storm surge and one map, many futures. Once the stakeholders are familiar with these key concepts, they're ready to jump into the maps, clicking the Explorer tab at the top. The first thing that they need to do is acknowledge a disclaimer, which basically highlights some of the intended uses of the Explorer for supporting regional planning, and also highlights some of its limitations. We can use the map interface to explore and visualize flood risk and exposure along specific areas of interest. And I'm going to highlight some of these functions while walking through a brief example of some work that we've done in the East Bay. So let's consider that we want to plan to assess for sea level rise and storm surge impacts along the Hayward Shoreline in the East Bay, specifically near the Hayward Shoreline Interpretive Center, which is an education facility in the East Bay that is just north of Highway 92. We can adjust the water level using the slider on the left-hand side of the screen to investigate at what water level the center is at risk of flooding. Here I'm dragging it up to 12 inches and 24 inches. We can see that the center is 24 inches is the threshold at which the center floods. So this represents 24 inches above mean higher high water. We can click the map to get additional information about how much flooding is expected there and why the maps are showing flooding there. This link provides a really useful description of some of the inputs to the, why the maps are showing flooding there related to sea level rise and storm surge, but also highlights some of the limitations of what the models do not include, including riverine flooding and flooding from groundwater. The Flood Explorer also helps us understand under what sea level rise and storm surge conditions this level of flooding will occur. And that's where this One Map, Many Futures window in the top right is very powerful. Here we can see that at 24 inches of total water, we can expect to see that same amount of flooding given a 5-year storm surge event. And so this part of the website really helps to connect the total amount of water with the different scenarios that you might be expecting to see that sort of flooding. And so we can see that the interpretive center here at the center of the screen is at risk of flooding at this water level. In addition to choosing the amount of flooding using the slider, the stakeholders can also select the specific combinations of storm surge and sea level rise that they want to visualize. Here I'm going to click the Choose a Scenario tab in order to make this selection. So in this example, a planner may know that they need to plan for 24 inches of sea level rise at mid-century, as well as a 100-year flood. And so I'm going to choose those two values and see the resulting total water level, which is 66 inches of water above mean higher high water. So these two methods of choosing the water level provide the stakeholders with a lot of opportunities to customize what they're visualizing in the map. In our legend, we see that our overtopping data is symbolized as these red and gray lines along the shoreline. And we can remind stakeholders what the definitions of these terms are using some of the visual cues that we've employed in our learning section. And we can see from the map that this overtopping, shown in red, is largely occurring along these channels, but not from the bay margin at 24 inches of sea level rise. So this gives us a good indication of where this flooding is coming from and where it is not. So now that we have a good understanding of the exposure that the center faces, we can begin to explore other functional vulnerabilities that may impact it. And this is where, through interviews with asset managers and of the interpretive center, we begin to understand that the building relies on water, sewer, and electrical utilities that are suspended underneath the floor. To help visualize these interconnected assets and vulnerabilities, stakeholders can upload additional data to help visualize these connections. Here, I'm choosing to upload, data from the California Energy Commission, basically a shapefile, a zip shapefile representing transmission lines, here shown in pink. And so we can begin to start piecing together how some of these related assets and the vulnerabilities of them may tell the overall story of how the asset that we're interested in is vulnerable. Once stakeholders have created the map that they're interested in, we have simple print functions that can help them print this map and share it with asset managers or other stakeholders. For the more technical users who have capacity with GIS, we are providing all this raw data available as geodatabase downloads that they can use for further analysis in their planning process. As stakeholders explore the flooding maps, we want to be able to direct them to where resources and ongoing planning efforts already exist for their area of the shoreline. By clicking on the map, we can also investigate what other adaptation efforts are happening around the region through this Get Involved link. This pulls up the Adapting to Rising Tides website, where we've tried to summarize where some of these education initiatives, vulnerability assessments, physical adaptation projects, and community-based organizations are already working and may provide useful resources for ongoing planning efforts. Here I'm clicking on the Hayward Shoreline Resilience Study that the Adapting to Rising Tides program completed. So in addition to the Bay Shoreline Flood Explorer, the ART program provides additional resources for helping our partners design and carry out planning process. And that's where sections and materials found on the ART website can be very useful in supporting other stages of the planning process. So that's our summary of how this tool can be used to support stakeholder engagement, understanding of flood impacts, and helping to share and connect stakeholders with the data they need to understand what's at risk, as well as what efforts are already happening and how they can participate and or design a planning process to create more resilient shorelines along their stretch of the coast.